Fuel injector testing is best done right at the injector. There's two tests that we can perform, the current waveform or the voltage waveform testing. Voltage testing uses the ground, the control side of the injector, as you can see here. Current testing uses the B plus or the ground side. It does not matter. You just have to turn the probe over. For voltage test, connect the lab scope to the ground side, the control side of the injector as shown here. And you're going to get that pattern. Let's blow it up so we can look at it. Reading from left to right, the first thing we should see is available voltage to that injector. It should be normal B plus, within a half a volt of B plus. If it isn't, test the fuse and the wirings to the injector. If the fuse and the wiring is good, go to charging system test, because if that's lower than normal, you have a charging system problem. Next, look at the ground, the on time of the injector. It should be under 0.2 of a volt. The PCM is going to supply the ground for the injector. If the ground voltage is over 0.2 of a volt, check the wiring from the injector back to the PCM. If the wiring's good, go to PCM testing. The inductive kick after the PCM turns the injector off should be equal to all other injectors. Compare them to the other injectors on that vehicle. If it isn't and the ground and the B plus is normal, replace that injector that's odd. Current testing is done during the injector's on time. We're going to place that low current probe around the ground side in this example, but we can turn the probe over and put it on the B plus side. Right on the left-hand side of our waveform, we can see the start of current flow, where it begins to flow. The hump indicates the pintle opening. All the injectors should open about the same position in the waveform. Different scopes depict the pintle opening better or worse. This one, it's difficult to see, but if you look there, you can see a slight difference. This is the pintle opening on our scope. Opening lower on the waveform indicates that we have a weak closing spring in the injector, which may result in a rich condition. Opening higher on the waveform indicates a dirty or sticking injector, which could result in a lean condition. Then compare peak amps to specifications. You can see we have 0.97 amps, almost a full amp, and our spec at the bottom of the screen there says from 0.6 to 1.1 amp. We're within specifications for this example. Higher amps are most likely shorted injectors. This is an example of a low injector current. Make sure that the battery B plus is present at that injector, because bad PCM drivers are the most common reason for injectors with low current, but you got to make sure that B plus is present before you start thinking replace the PCM. If you have good B plus, go to PCM testing.